Good afternoon or good morning, depending where you're located. My name is Mark Knight, and I'm going to be the moderator of this session. I'd like to thank you for joining the 14th Canadian Underground Infrastructure Innovation Center Academy Webinar for the presentation on Watermain Rehabilitation with Same-Day Return to Service, presented by Andrew Hallett with the Public Utility Commission of Sault Ste. Marie. CUIIC Academy. This event is organized by the Canadian Underground Infrastructure Innovation Center, the University of Alberta, and Benjamin Media. The CUIIC Academy offers classes, courses, webinars, and events to help further underground infrastructure educational opportunities across Canada. The CUIIC Academy webinars happen every third Thursday of the month. Please join us for the next installment on March 21st. Award-winning custom built drones for surveying buried pipelines and confined space, presented by Shauna Heron, Director of Environmental Techniques. I'd like to note a few upcoming CUIIC Academy events. March 13th to 14th in Richmond, BC will be the second 2024 Pipeline Rehabilitation Academy. And in April 24th to 25th will be the CUIIC Advanced HD School. And there's more information on the CUIIC website on that. To learn more about the events, including registration and sponsorship opportunities, please visit the CUIIC Academy website at academy.cuiic.ca. So that's academy.cuiic.ca. I would like to thank our webinar series sponsors, Westlake.
I was asked to share a little bit about our journey implementing a spray-in-place pipe program, and we'll talk a bit more about what led us to choose spray-in-place pipe as an alternative for infrastructure rehabilitation, and share with you some of the tools we use in our cleaning, lining, and disinfection process that enabled us to provide same-day return to service. So this is probably a familiar story for a lot of water professionals, but as municipal and economic population growth rates have varied over history, so has construction of municipal infrastructure. In Sault Ste. Marie, a construction boom beginning with the end of World War II and lasting some 25 years accounts for the single biggest age cohort of water mains in the city. Predominantly made of cast iron, corrosion processes are the principal cause of deterioration of these pipes. The PUC reasonably anticipated a wave of infrastructure renewal at rates considerably higher than conventional replacement programs provided. Inflation of renewal costs was also anticipated. The PUC had a need to address this potential burden to its ratepayers. Now, we're not alone. In 2018, the Utah State University report on water mains in the US and Canada described corrosion as a major cause of main breaks, described the average age of failure of water mains as being 50 years. The study also found that over 40% of water mains were of iron or asbestos cement, both of them subject to deterioration over time. So while a proven practice, replacement of water mains is costly. The past practice of replacing pipes would clearly place an unwelcome burden on our ratepayers. Under our strategy, water main is replaced only where required. Service life extension can be completed at a lower cost and address more pipe for the ratepayer's dollar. By extending the service life and deferring the cost of replacement, the burden to the ratepayer may be spread out over more years, normalizing the cost to the customer. A dig and replace or open cut water main replacement project, the length of a city block, can take months to complete, especially in built up areas. Unless combined with storm and sanitary replacements, dig and replace can be prohibitively expensive. Because storm and sanitary pipes may not require replacement at the same time as water main, other tools may be of better value. Sault Ste. Marie also has a conventional pipelining program using cure-in-place pipe. Each lining section typically requires several weeks to complete at a pace that eclipses trench excavation and pipe replacement. Conventional lining is often deemed a fully structural liner. Requiring several weeks from start to finish, temporary water systems are essential for conventional lining methods as well as full pipe replacement. Temporary water systems are a cost that does not provide value over the life of the renewed asset. The ability to forego a temporary water system would reduce the costs and accelerate the pace of renewal. Spray-in-place pipe offers the possibility of same-day return to service if timelines for cleaning, disinfection, and lining can be sufficiently compressed. With a same-day return to service, the cost of temporary water systems can be avoided, and that savings applied to increasing the amount of pipe renewed. In 2020 and 2021, the Sault Ste. Marie PUC piloted Watermain renewal by spray-in-place pipe, anticipating we could reduce neighborhood and traffic disturbance, progress faster than alternatives, realize savings from reduced labor, reduce or eliminate temporary water systems for added savings, and increase productivity overall, and most quickly intercept this wave of aging infrastructure. PUC engaged a third party to evaluate this pilot program. As Mark Knight indicates, he was involved with, through University of Waterloo, the evaluation of both years of that pilot program. And a favorable conclusion led Sault Ste. Marie PUC to establish subsidiary Watertight Lining Solutions in late 2021. Over the course of 2022 and 2023, equipment was procured, a lining team was trained, and Watertight Lining Solutions completed its first season of pipelining. So we'll look at some of the tools that we use in the lining program. Fundamental is this sort of work structure we have, which we refer to as a 6-step process. And it covers the lining program sort of from inception and assessment and planning to completion and reinstatement of the pipe. Prior to selecting a rehabilitation method or deciding to replace a water main, we need to clearly understand what we're trying to achieve. The objective of replacement and rehabilitation is to restore the required function of the pipe. Loss of function may be in relation to reliability due to frequency or nature of breaks. Loss of function may be in relation to substandard fire flow as a result of tuberculation and lost capacity. Loss of function may also be in relation to substandard water quality caused by buildup on interior surfaces of the water mains. Due to the extensive water main infrastructure, a system owner may lack exact information on individual water mains. Most owners, though, have a considerable knowledge base that can help inform their design objectives. This information might include pipe age and material, soil types, corrosivity, and various testing results, such as hydrants and C factors. Operating records, such as break repairs and operator reports, are also valuable sources of information. Once design objectives are clear, we're best positioned to select the appropriate tool to restore the desired function. Information requirements can differ for lining than for replacement projects. Lining equipment, for example, might not be able to negotiate bends in a water main. Plan and profile information is desirable to identify these areas. With older pipes, however, profile drawings may not be available. It's good practice to identify potential areas where deflections may have been used and investigate prior to construction. For example, installation of a sewer main may have required additional vertical bends in a water main to prevent the pipes from intersecting. Investigating sewer elevations from access holes and water main elevation from valve boxes can provide insight into areas where bends may have been installed. Locates of other utilities can help determine where trench boxes can be safely installed and if any utilities may pass through the trench box. Advanced consideration of constructability of trench boxes can prevent delays and costs associated with poorly situated trench boxes and help understand what's going to be in the way when working inside trench boxes. Additionally, valves and customer shutoffs used to isolate the pipe being lined need to be verified in working order to ensure they will fully close during lining operations. It's also important to give operational consideration to the pipes that are being lined. There needs to be a clear understanding of the extent of and duration of the service interruption, implications on fire protection, any vulnerable persons connected to the system, and essential services. Some of these, and depending on the role of the water main in the system, may require a temporary bypass. Thorough construction drawings can help us address the unexpected. There are no street signs inside the pipe. The more information that can be provided on drawings, the better. During pipe inspection, when more services are found than are provided for on the drawings, accurate locations of services on the drawings will help distinguish which services should be abandoned and which should be reinstated. These are some common steps that can be taken to prevent surprises that could delay the start of lining. Because trenchless solutions often leaves roads open to traffic, good traffic management is also essential. So we'll take a closer look at some of our cleaning and lining tools. Through its initial pilot program, P.UIIC evaluated 2 cleaning systems and found that cleaning times could be significantly reduced using the Tomahawk cleaning systems. Tomahawk uses a vacuum truck connected to the main to generate sufficient airflow and speed to fly abrasive stone in the pipe. Axial movement of the stone scrapes the pipe wall with a result similar to sandblasting. The system uses an auger to control the feed rate of the stone, as well as to control the airflow in the pipe to adjust the intensity of the cleaning. The end result is a bare metal pipe wall, assuring a strong bond between the liner and the host pipe. Monitoring airflow and speed relative to benchmarks for a clean pipe helps determine when cleaning is complete. The process is suitable for cast and ductile pipe, steel pipe, and asbestos cement pipe. When we cleaned asbestos cement pipe, we fitted the vacuum truck with HEPA filters and a water wash on the incoming airstream to safely contain any asbestos within the truck. There's a thorough procedure in the Tomahawk specifications and manual for addressing asbestos cement pipe. Following cleaning, the Scout camera is deployed to record CCTV video inside the cleaned pipe. The Scout camera is propelled using airflow, again generated with a vac truck. Pipe wall is also dried with the process, as the pressure drop associated with air accelerating around the probe helps evaporate water from the pipe wall. The same process helps remove water from small surfaces and joints. An optional step available at this time is to deploy an evaluation tool to determine the remaining wall thickness in the iron host pipe. In the event the project objectives are not adequately informed, remaining wall thickness can guide on-site engineering decisions, including selection of a lining thickness, specific locations requiring repair, or identifying the need for cathodic protection. We found 2 to 3 hours was generally sufficient to set up and complete Tomahawk cleaning on 6-inch diameter water mains about 130 meters in length. Materials collected in the vacuum truck is a mix of tuberculation materials and stone and is more easily disposed of than liquid waste associated with water jetting. Now we'll take a look at the spray-in-place piping system. The polymer system used for the pilot studies and subsequently adopted by Watertight lining is Resiline 320. The polyurea lining is certified to NSF 61 standards, a benchmark for acceptance for use in drinking water systems. This class of polymer has been used for decades in the UK. With a build rate of 3.5 millimeters per coat and up to a total thickness of 14 millimeters, This polymer can be used as a corrosion barrier to improve water quality or hydraulic performance, or to structurally enhance the pipe. The polymer has a rapid cure time, being dry to the touch within about 2 minutes. The surface is sufficiently hardened within 15 minutes to deploy a robotic camera for quality verification, and additional coats may be applied within an hour. The schematic below shows the lining head being towed from a launch pit at left to the retrieve pit at right, as the lining head, shown in the upper left, applies a coating to the pipe wall while it's being winched backwards towards the lining truck. Automated control over winch speed and flow rate provides a uniform thickness of coating within the pipe. The lining rig heats and shears the polymer to maintain optimal properties. Automation of feed rate and winch speed, again, ensure uniform thickness, and weight checks are done prior to coating to ensure proper mix ratios. Flow meters monitor mix ratio throughout the lining process, and the overall lining process is subject to an NSF approval. We'll take a look at a pipe inspection. Following each lining, a robot camera is deployed in the pipe to document any defects and inform follow-up if required. Resiline has a design manual available to assist with classifying defects and guiding remedial action. In addition, corporation stops may be examined for obstruction. If blockage is excessive, the robot carries a drill which can be used to open up the surface connections. Testing has shown that coatings of 3 mm thickness and less do not normally require drilling. Cameras and cables are cleaned prior to use and wiped and sprayed with chlorine solution before entering the pipe. We'll look at reinstatement. So the province of Ontario has developed a procedural document that provides further guidance beyond AWWA C651 and has a section specific to lining water mains. In Ontario, as a first step, it's important to always consult with a local medical officer of health prior to starting a lining project and make sure that the medical officer of health agrees with the reinstatement process. After lining, the water main can be flushed, disinfected, and microbiological samples collected. Subject to agreement with the medical officer of health, the pipe may then be filled and returned to service, maintaining isolation from the rest of the system using backflow preventers until such time as favorable results are received. Alternatively, the medical officer of health may impose a boil water advisory if the pipe is reconnected. The foregoing represents an alternative to the cost of temporary water systems, which may still be desired at the discretion of the operating authority. It's a risk-based approach consistent with Ontario's approach for water main breaks. Where conditions are controlled and contamination is not suspected, less stringent measures are applied to reinstate. If at any time contamination is suspected, then reinstatement procedures escalate. A reminder to ensure certified drinking water operators are present to make operating decisions such as this escalation when required. Over the first 2 years of pilot lining in Sault Ste. Marie, line pipes were reinstated prior to receipt of test results, but under a boil water advisory. During this time, bacteria test results were consistently favorable. In 2023, we were permitted to immediately reinstate lined water main, properly isolated with backflow preventers in advance of receiving microbiology results and without a boil water advisory. Ontario's risk-based regulatory approach enables same-day return to service, faster and more efficient infrastructure renewal, and with less disruption to the public and less traffic risk. The tool we use to disinfect the pipe, we tested a new device from the UK, a steric lens from Sure BPH. The AWWA C651 spray method is also expanded on in Ontario's procedures for water main disinfection. The spray disinfection is advantageous because the quantity of chlorine used may be reduced along with the risk to the environment and disposing of superchlorinated water. The steric lens system emulates a spray-in-place lining rig, only the inside of the pipe is coated to a prescribed thickness with chlorine solution. Because pump rates and winch speeds are automated, a uniform thickness of chlorine solution can be applied quickly and with consistency. Chlorine concentrations may be recorded from day tanks before and after spraying the pipe to confirm concentrations meet standard requirements. Flow and speed may also be used to verify coating thickness. In addition, because higher concentrations of chlorine are used in the spray method, contact time may be reduced to as little as 30 minutes under the AWWA and Ministry of Environment of Ontario procedures, whereas normal disinfection times can be as much as 24 hours. The use of the SteriCleanse system is one more step where we've been able to compress the required time required to reinstate the water main. Various technologies have been combined to deliver spray in place lining, disinfection processes to deliver same-day return to service. And Mark, I guess at this point we can open up some discussion on some questions.
Yeah, great job, Andrew. There's some questions here that the audience has got in. The first one, in terms of lifespan and durability and the quality of the lining, how does SIPP compare to CIPP?
So I know that the manufacturer's literature on the polymer, they're looking at service life in excess of 50 years. Mark, you might compare that with some observations of yours on CIPP.
Yeah, I think it's important to note that CIPP can be designed as a Class 4, AWWA Class 4 lining system. And right now, SIPP is considered really a Class 3 lining system. So the difference is the CIPP does not rely on the hose pipe. The SIPP right now is relying on the hose pipe for the duration of the life of the lining system. So we're going to bridge holes and gaps, and we'll be able to, as a Class 3 liner, you have enough ring stiffness to withstand vacuum and other conditions. So I think the idea here is that we're definitely going to give life extension, and if you probably put SIPP with cathodic protection, do you think that would extend the life of the existing iron pipes quite a bit in your area, Andrew?
I think it would. I think there's a number of cases where, and I think part of this goes back to the design objectives. One of the things that we need to understand when we start out is whether the pipe is deteriorating from the inside out or whether the pipe is subject to external corrosion. So with the lining on the inside of the pipe, we can certainly address and arrest further deterioration from the inside. And if we believe that external corrosion is also a factor, it's certain that a number of municipalities have implemented cathodic protection programs and have seen reductions in main breaks following that, as an example. So I think there's just like we've sort of mixed the tomahawk cleaning process with the spray in place process with the pipe disinfection process, there's also room to add pipe evaluation into the pipe assessment process while we have it open, and we can draw additional conclusions at that point about whether we have a follow-up to for example, install external cathodic protection. So I think there's the opportunity to combine internal and external corrosions to further extend that corrosion protection to further extend that service life.
Yeah. So do you see SIPP as a replacement for CIPP or just another tool in your toolbox to be able to that maybe not all lines that are going to be rehab need to be CIPP, but you can do it hopefully with same-day return to service? Yeah.
Yeah, I think that's fair. I'd characterize spray in place, pipe replacement, CIPP, all as tools in our toolbox that, depending on our design objectives, those objectives will probably guide us towards one technology or another.
Good. So another question here says, what factors led you to provide services in-house versus using contractors?
So to some extent, we are, Sault Ste. Marie is about 700 kilometers from Toronto. It's a little bit more remote community in terms of accessibility to some of the higher tech rehabilitation solutions. And we saw an opportunity for being able to restore some of our system at a competitive price, and not necessarily having ready access to some of the specialized contractors here. And we also saw the opportunity. The PUC group of companies actually serves a number of water systems in northwestern Ontario and northern Ontario that could potentially benefit from the technology as well.
Great. You're kind of like the EPCOR of northern Ontario in some ways.
That's right.
So there's another question here, which is, did you see any significant accumulation in the asbestos cement pipe as compared to what you would see in cast iron?
That's a good question. We did not. In fact, when we cleaned the asbestos cement pipe, we wanted to do what we could to mitigate any fibers and release of those fibers. We had the option of cleaning the pipe with aggregate stone, but we chose first to use the vac truck to pull swabs through the pipe. And so we would pull probably 6 to 10 swabs through the pipe. And following that, we could run the Tomahawk Scout camera through the pipe to dry it. And we were quite satisfied with the results we saw. We didn't see tuberculation in the classic sense on the inside of AC pipe. It was mostly presumably a biofilm and some possibly some cement that was maybe able to be moved when we applied the scraping of the swabs. But once we pushed some swabs through, really the pipe, once it was dried, it looked to be in very good condition. And I think, Mark, we took some coupons to you for some evaluation, and as I understand it, the adhesion of the polymer to the asbestos pipe wall was quite high.
Yeah, it was. We've just we removed the liner, but it was fully bonded to the asbestos pipe, and it was actually the pipe itself that peeled off, not the liner off the inside of the pipe. So there was really good adhesion of the liner to the existing hose pipe. Tomahawk pipe cleaning system, as you say, is not to be used on that one. There's a question here about getting a copy of the presentation. That will be made available through, I guess, CUIIC if we can follow up on that one itself. There's a question here again on AWWA M28 pressure classes and for CIPP product, but I think that is class right now for Resiline 320 is class 3. I know that there is some research work that is going on with the possibility, and the main reason for class 3 is the question around whether or not it will survive a ring break, pipe ring break on that side itself. So on that side.
I think there's another element there, Mark, as well. With the spray in place, we have the ability to use a class 1 coating. So it's also available as a potential alternative to cement mortar lining. Or if our objectives are just trying to deal with a water quality issue and we don't have a structural issue, we can protect the inside of the pipe at a class 1. We can arrest deterioration at that stage, and if the pipe is still in good condition, we can still contribute to extending the service life of the material. I think the ability to be flexible with this solution and apply it at a class 1, 2, or 3, and hopefully before long at a class 4. I think that's a lot of the strength of this alternative. You can customize the thickness to the job site and to the need based on the objectives.
So we've got a lot of questions, and unfortunately we won't be able to answer them all, so I'm going to leave it just one last question for you, Andrew. We'll try to answer people's questions. We'll give you a response. We haven't answered the question. What about the drying time? There's a question here around, and I think it's an important one. After you apply the coating on the inside of the pipe, how long is it before you can go back in and see that coating and put a camera in? And then if you're going to, I think you said you can add 3.5 millimeters at a time. And what's the recoating window time? When can you go back in again and add another 3.5 millimeters to build up the lining?
Okay, so we can go in and apply a second coat within an hour. We can begin a disinfection process within an hour. There's an additional element there. We have a recoating window of actually 6 hours. So if you provide a first, second, potentially third or fourth coat, if your successive coats are within the 6-hour window, you get a monolithic liner. There's no ring between one coat and the second. There's no delamination point. You've got a monolithic liner. If that 6-hour window is exceeded, you could still, for example, use Tomahawk to basically rough up the inside of the pipe, ensure a good mechanical bond, and apply an additional coating after that. So you do have a lot of flexibility. And again, we can put a camera in the pipe within 15 minutes of applying polymer.
Yeah, it's a very fast setting polymer, very different than other polymers that were in the market before that were also fast setting. There's very little shrinkage in this one, and we see that you get very good bond to the hose pipe. So Andrew, I think this technology is very exciting. I really look forward to see how it's going to develop and move into the marketplace in the next couple of years. And I really want to thank you for your contribution to the industry to be able to help push this product and into the marketplace, and for making same-day return to service possible, because one of the things I've always thought was possible in the marketplace, but it's finally nice to be able to see that it is here. I would like to remind people about the 2024 Pipeline Rehabilitation Academy. That's going to be March 13th and 14th in Vancouver, BC. This is a 2-day event. That day one focuses on gravity pipeline rehabilitation, and day two really focuses around potable water. If you really want to learn more about SIPP and CIPP for Watermain Rehabilitation and these types of products, it will be a fantastic place to be able to go and find what the state of the art of these rehabilitation technologies are for both wastewater as well as pressure pipe on that side. So Andrew, once again, thank you very much. Thank you for attending and sending in your questions, and make sure that you sign up for the next webinar on March 21st, award-winning custom-built drones and surveying techniques by Shauna Heron, Environmental Techniques. And once again, a call out for our series sponsor, Westlake Pipes and Fittings. So see you at the next webinar on March 21st or at the event in Vancouver. Thank you very much. Bye.